Hello, welcome to the Autonomous Drone Engineer course. This is module B1, Introduction to Autonomous Drone Architecture. Before we talk about the technical details of the hardware and software architecture, we really need to define your project. Is it an unmanned aerial vehicle, what we call UAV, or system, UAS? What is the level of autonomy you need for your project? What is part of the flying intelligence and part of your payload, potentially for your client payload? And what is your business model? Are you selling hardware or a service? First, is it a vehicle or a system? With remotely controlled drone, you have a drone and a pilot. With autonomous drone fleets, you're removing the pilot, but the drone is not left alone. IT systems have several services to help your drone fly. For example, mapping, flight authorization, data storage, data analysis. In fact, such drones are only a small part of a very large IT system. They are the packs that are acting with the physical world by capturing data or moving objects, in the case of shipping. So if your drone is autonomous and targeting the professional market, it is very likely a UAS, a system. Now let's focus on the different level of autonomy for a drone. Being smart for a drone means integrating two opposing constraints. First, you have to be able to follow mission, plan or before the flight, or define on the fly. It's a bit harder. All of that while avoiding problems like collision with random objects. And having the two interact closely is really what we are after to talk about autonomy. Examples. A low level of autonomy for a drone is following simple instructions like a given GPS path without any additional features. A higher level of autonomy is follow the same GPS path but being able to stop to avoid collision and to land or to go back, for example. A highest level of autonomy in our example is following the same GPS path, avoiding obstacles, and be able to adapt and redefine the mission depending on obstacles. For example, I have to find an object in a field. If I see that I have a lot of humans in a part of the field, I will focus on the other part of the field because it's safer to fly there. That's the highest level of autonomy for a drone. Your drone may be autonomous for a certain part of the flight and not others. For example, perhaps the drone can follow GPS path at high altitude but requires a pilot to take off and land. Or is it able to avoid collision at low speed, close to the ground, but requires supervision when flying at high altitude, high speed? A fully autonomous drone requires different solutions for different flight phases, so you have to specify your needs very clearly. Now, your drone may have a flight stack to fly, obviously, but they also carry software and hardware that your client needs for a specific work. They have very different characteristics, solving different problems, and it's not always easy or useful to have them interact. For example, a drone deployed over a mine may have a full 3D short-range sensor to avoid collisions, plus a 3D long-range sensor to scan the mine and build a 3D model. But the LiDAR used for long-range sensing may not be useful to avoid collision, and the short-range sensor may not be useful to scan the mine. So, for example, illustrated here, we have the FlyLab solution to avoid collision, but also scan the ground. Now, let's talk about business models. Because we use the word drone, it may be tempting to think that we are selling hardware. It's supposed to be obvious. Well, it is not obvious at all. Professional clients can buy a remotely controlled drone to perform some tests and perhaps one autonomous drone to test their software, but they will likely outsource their drone operation to specialists, just like they do for their helicopter or jet fleets. And there's a few reasons for that. First, flying professionally carries a very strong legal responsibility, and big companies understand that very quickly. Also, maintenance and operation will probably be cheaper for large fleets if they are shared between several clients. So it makes sense to outsource to drone operators that will share drone maintenance between clients. And you also want to focus on their differentiator, what they want to own and have full control over is the payload, the software and hardware and methods that are used by the drone to accomplish their task. To summarize, you have to be specific. Are you providing a core technology for drone manufacturers or operators to use? Is it a drone as a hardware business model, or are you selling services? And most likely, if you are in the professional drone business, you are selling drone-based services. To summarize, each drone solution is highly specialized, dedicated for a specific task. So be clear about your goal and expectations because there is no perfect drone that is able to do everything. The architecture will be a lot easier to define and your drone solution easier to position on the market.